Okay, so we are on page 12. So we are going to first start by writing our equations in slope-intercept form. Okay? How do you know you can write your equation from a word problem in slope-intercept form? You're going to use this when given a rate of change. What's a synonym for rate of change, guys? Somebody said it. Slope. So our M. And a starting value. What do you think would be a synonym for a starting value? Your y-intercept, or your b. So you only can write your equations from word problems in slope-intercept form if you have the rate, okay, and if you have a starting value, okay, a starting. So who wants to read number 1 for me? Michaela, you'll read number 2. Does that work?
Evan is going to the country fair this weekend. The admission to the fair is $5 and the cost of the ride is 50 cents. If his parents gave him $20, write and solve a linear equation to find how many rides he bought.
Great job. Okay, so the admission to the fair is $5. Okay, how many times are you going to pay that $5 fee? Just once. So that's your starting cost. Okay, it costs $5 just to go in. Okay, so that is your B. That's your base fee. You have to pay $5 to get into the fair, even if you ride no rides. Okay? Then it says the cost per ride. Guys, this word, per, is going to help us identify our rate. Cost per ride is 50 cents. So what do we think our M is? 50 cents. Now be super careful. How would I write 50 cents? 0.50. I'm going to write it like we would write money. I'm not going to just use 0.5. I'm going to do 0.50 for 50 cents. Are we okay with how we identified our M and our B? Okay, don't worry about the $20 yet. We're just writing the equation. Okay? I have my M and my B, so I can write it in y equals mx plus b form. So y equals 0.50x plus 5. Good? Now it says if he is given, if he is given $20, how many rides can he ride? So is that 20 going to be my x or my y? Your y, because notice it says the cost per ride is 50 cents. What are we multiplying 50 cents by? X. So that means x is my number of rides. 20 then is how much money you have. So that's your y. So this is my first answer. That's my equation to represent the situation. Now I'm going to replace y with 20. So I get 20 equals 50 cents x plus my $5 base fee. Draw our line through the equals, and we want to circle and solve for y. What am I going to do to solve for y? So we want x by itself. What's on the same side as the x? These two numbers. So those are the two I need to move away. Which one's not glued to it? Which one's my constant? The 5. How do you get rid of a plus 5? Minus 5. Very good. So I'm going to minus 5 on both sides. So then I have 20 minus 5 is 15 equals 50x. Keep your x circled. What do I do now to get x by itself? Divide by 0.5. And we get x equals, what's 15 divided by 50 cents? 30. Okay, so how many rides can he ride? 30 rides. How many of us have ever gone to a fair? Do you think you could go to a fair and spend $20 and ride 30 rides? Oh my goodness, no. One ride normally costs like 20 bucks. Okay. So this must be the discount fare. Are we okay with that? So I have two answers. One for the equation and then one, how many rides can he ride if his parents give him 20 bucks? Good? Okay, number 2. Alex, will you read number 2 for me, please?
While visiting Kingston Lake, Valley decided to go kayaking. The rangers charged $8.5 or $8.50 per hour. In addition to $25 deposit to rent a kayak. If she rented the kayak from 11:30 a.m. until 2:30 p.m., write and solve a linear equation to find the total cost for the kayak.
Very good. Okay, so we need to see if we have a rate and a starting value. Okay, so it says that the rangers charge $8.50. We see that word per again. Per hour. So that means that $8.50 is my what? My slope, my rate. So M is $8.50. Then it says in addition to a $25 deposit. Do you pay a deposit multiple times or just once? Just once. That's your base fee, your starting value. So that's your what? Your B. Very good. Your y-intercept. So I have my M and my B. Can I write my equation? Yes. Y equals M X plus B. And there is my equation. Then it says if she rented the kayak from 11:30 until 2:30. So, 11:30 until 2:30. How many hours pass? 3 hours pass. Okay, is hours your X or your Y? The way I would look, we have 850 times X. 850 per what? Hour. So hours is your X. So X is 3 hours. Do we see why this time they're giving me the X and not the Y? What does the Y represent in this situation, guys? Total cost. Good job. Okay. So when I rewrite my equation, I'm going to replace X with 3. So Y equals $8.50 times X, which is 3, plus $25. Can we put this whole right side in the calculator? Yep. Do it. Tell me what we get. What's the cost? Now, if we're talking about money, would I ever say $50.5?
$50. No,
50 cents. $50.50. When we're talking about money, guys, you have two options. No numbers after the decimal or 2 numbers after the decimal. You can't ever have 1 number after a decimal when we're talking about money. Okay? Are we good with our slope-intercepts? Yes? We're sleepy today, huh? Okay, let's go now to standard form. Do we remember what standard form is, guys? AX plus BY equals C. Okay? AX plus BY equals C. Now, when do we use this? You are going to use when the problem relates to different objects. So this one we're not going to have a rate and a starting value. Okay? This would be like comparing the cost of apples and the cost of oranges. You go to the grocery store, you buy apples, you buy oranges, they're going to have different costs, right? So this is when I would use standard form. Okay, we're comparing two different things. Okay, so it says, Sam ordered 2 hamburgers and 3 hot dogs from the concession stand at the basketball game. His bill came to $19.05. So let's just stop there. Okay. What are the 2 things that I'm comparing here? What 2 things did he buy? Hamburgers and hot dogs. So let's say X is my hamburgers and Y is my hot dogs. Do I know the cost of one hamburger? Well, don't read that yet. From the first sentence. Do I know the cost of one hamburger? Do I know the cost of one hot dog? No, but do I know how many he bought? Yes, how many hamburgers did he buy? 2 hamburgers. So how am I going to write that? $2X. Does he buy more than just hamburgers? Yeah, he also buys hot dogs. So plus, because when you buy more stuff, your cost goes up. 3 hot dogs, and hot dogs are Y. So 3Y. For a total cost of $19.05. So that is my standard form equation. 2 hamburgers plus 3 hot dogs equals a total bill of $19.05. Good? Now, Dylan, how much does my hamburger cost? So I can replace what variable with 525? X, because X is the hamburger. So X is 525. So I'm going to rewrite my equation, but I'm going to replace X with 525. So 2 times 525 plus 3Y equals 1905. Draw your line through the equals. Okay, what is 2 times 525? So 10.50, because we're still talking about money. You want 50 cents. Plus 3Y equals 1905. I want Y by itself. What am I going to do to get Y by itself? Subtract what? Subtract 1050. Very good. And then I have 3Y equals, what's $19.05 minus $10.50? $8 and what? 55 cents. Very good. Keep your Y circled. What do I do to get Y by itself now? By 3. And we get Y equals $2.85. Guys, the thing I like about word problems is there's logic here. Is it logical that a hamburger is going to cost $5.25 and a hot dog is going to cost $2.85? Yes. Probably not like if you go to the Astros game, they charge like $10 for a hot dog. But some places, normally our hamburgers are more than our hot dogs. Okay, are we good with that? Was there anything, or no, I'm not going to say that. Okay, number 6. Who wants to read number 6? Bingo.
Tickets at a school cost $4 in advance or $5 at the door. Total ticket sales for an evening production were $440. If no tickets were sold in advance, write and solve a linear equation to find the how many were sold at the door.
Very good. Okay, so what two things are we comparing here? Tickets that are sold at the door and sold in advance. So I'm going to say X is advance. And then Y is at the door. So sorry, y'all can't see that. How much are our advance tickets? $4 per ticket. So how would I write that? 4X. Very good. We're selling more than just advance tickets. So plus, how much are the door tickets? So 5. Why? For a total cost of what? $440. That's the total. So there is my standard form equation. AX plus BY equals C. The X and the Y are on the left, the C, the constants on the right. Okay? We're not doing all of them. Okay. Now it says if no tickets were sold in advance. No tickets sold in advance. What is that telling me? What variable? X is what? 0, because none were sold. So in advance is my X, so this is telling me X is 0. So I'm going to rewrite my equation now, and I'm going to replace X with 0. So 4 times 0 plus 5y equals 440. Draw your line through the equals. Well, what is 4 times 0, guys? So do I even need that? Nope, cross it out. Circle your y. What do I do to get y by itself? Divide both sides by 5. And we get y equals what? 88. Okay. 88 what? Word problems need units. Like up here we had 30 rides. $50.50, $2.85. 88 what? Tickets at the door, because it's Y, and Y is your door ticket. So 88 tickets at door. How are we feeling with our word problems, guys? Okay, skip. We are going to page 15. We're done with word problems for now. Okay. We are now going to scatter plots. I'm zoomed in. Okay, so what is a scatter plot? Have we heard this word before, guys? Yes. Do we remember what it means? Okay, let's think. What does the word scatter mean? Everywhere. And then if we're plotting our everywhere dots, it's just, this is a scatter plot. Okay? So, a scatter plot shows a possible relationship between two variables. Shows a possible relationship between two variables. Now, if I give you two pieces of information, if I give you two things to compare, is there a relationship between all two things I tell you? Think of it with like people. If I pick two of y'all randomly, does that mean you have a relationship? Like, are you friends or are you dating? No, not necessarily. Okay, so scatter plots just show a possible relationship. Sometimes the data that we're looking at, there's no relationship at all. Okay, sometimes we're going to have good relationships, or we're going to have bad relationships, or we have no relationships. Okay, so positive, negative, or none. Okay, these are 3 different types of scatter plots we can have. Since we're looking at real-world data, it normally exists in the first quadrant. Okay, because most things, like if we're doing distance and time, those both have to be positive. If we were doing hamburgers and hot dogs, both those have to be positive. Okay, so draw 3 coordinate planes, but really just in the first quadrant. We are going to look at what our positive, negative, and no correlation are. Okay. Okay, so looking at positive. Positive correlation is the same as having a positive slope. So reading your scatter plot from left to right, the points should go how? Up to the right. Is it going to make a perfect line? No, they're scattered about. But if I look at these dots, do those look like they are gradually going up from left to right? Yes, but is it a perfect line? No, because when we're looking at real-world data, it's normally not going to be perfect. Okay? So what do you think negative correlation is going to look like? It's going down from left to right. Same thing, not making a perfect line. What do you think no correlation or no relationship looks like? Looks like my graph got chicken pox. There's no rhyme or reason to those points we plotted. Okay? So, like I said, most data in the real world is going to be a scatter plot. It's not going to be a perfectly straight line. But we want to look at a line to help us predict information in the future. Okay? So, that's where we then come up with a line of best fit. Okay? A line of best fit is given a positive or negative correlation. Correlation just means relationship, guys. It is possible to write a prediction equation. Good? So when we are drawing or writing our line of best fit, do you think that all the points are going to be on the line? No. If I graph 4 different lines, so like looking at this first example, if I graph those 4 different lines, how would I know which one is the best prediction? How do we know which line to choose? We want our points to be what to the line? Pretty close to it, right? We want the line to go through the data points. Okay? So what we're going to do, we're going to graph all three of these lines on my graph. So looking at line A, what's my M? What's my B? Positive 80. Before we even start, guys, we could do a little bit of process of elimination. Okay? This has what kind of correlation? Negative. So my slopes should all be negative. Here I have negative slope. Here I have negative slope. Here I have negative slope. Here, this is what? This is a HOI. This is a horizontal. So do we think this is going to be the correct answer? No. Does this data make a perfectly horizontal line? No. So it's definitely not this one. Looking at your answer choices first will save you a little bit of time because we don't have to graph all of them. Okay? So let's graph our first. We're going to begin at 80 on the y-axis. Okay? Be careful by what you're counting by, guys. Okay? So on my x-axis, we're counting by 5, 10, 15, 20. We're counting by 5s, right? Are we counting by that same amount on my y-axis? Yes. 50, 55, 60, 65, 70, 75, 80. So are we counting by 5s on the y-axis as well? Yes. So I can go down to right 3 from my beginning point. Down, 1, 2, right, 1, 2, 3. Down, 1, 2, right, 1, 2, 3. I can do this since my axes are counting by the same values. Down, 1, 2, right, 1, 2, 3. Down, 1, 2, right, 1, 2, 3. Draw that line. And I would label it A. So I know which one that is. Does it look like that's a good representation, guys? Starts out pretty good, right? But then look at where I am at the end and look where I am over here. Do you think that's good then? No. Okay, let's look at line B. What's my M? And what's my B? So I'm going to begin at 75. And I'm going to go down 1, right 3. Down 1, right 3. Down 1, right 3. Keep following that pattern. Down 1, right 3. And draw your line. So that one's B. Does that green one, my B line, does that look pretty good? Are all the points kind of close to it? Do you have a good amount above it and a good amount below it? Because you wouldn't want all your points to be above the line or all the points to be below the line. Okay? Your line of best fit should cut through the data. So you should have some on it, some above it, some below it. Okay, let's try our C line. What's my M? And what's my B? So I'm going to begin at 80, and I'm going to go down 1, right 3, since my slope is 1/3. Down 1, right 3. And that's my line C. Okay. Do you think line C is good? Line C is above all the data points, right? It's not really going through the data. Okay, so out of these three lines, which one do you think is the best representation of all those points? B. B is my answer. Now, let's talk about if this is a strong positive strong negative, weak positive, weak negative correlation. The line's going down, so it's negative. Are all of these points really close to that line? Are the points pretty close to the line, guys? Yes. So this would be an example of strong negative correlation. Strong negative correlation. All the points are very close to that line. The more scattered out the points get, the weaker the correlation gets. Okay, the tighter or closer they are to a line, the stronger it is. Okay, we good? Okay, let's do the next one. What kind of correlation should this have? Positive or negative? Negative. It's going down. So let's look at our answer choices. What's my slope? Positive, not A. What's my slope? Positive, not C. What's my slope? Could be B. What's my slope? Could be D. Because this is going downhill, this has a negative slope, negative correlation, okay? So we're just going to plot these two lines, okay? So what is my M for line B? Yep. I was saying, what's my M for B? I know that was confusing, sorry. What's my slope for equation B? And then what's my y-intercept for line B? Perfect. So where am I going to begin when I graph this, guys? -2. I'm going to go up, and since it's negative, I'm going to go up to the left. So up, 1, 2, 3, left, 1, 2, 3, 4, 5. Or go 1, 2, 3 down, 1, 2, 3, 4, 5 to the right. And draw your line. And that is line B. Do we think that looks like a good representation, guys? There's some above it, some below it, but doesn't this data look a little bit steeper than the line we just drew? Okay, so let's do D. What's my M? -5/3. What's my B? So we're going to begin at 2, and I'm going to go up 5, left 3. Or down 5, right 3. That is a little off the graph. Okay. And that is D. Which one looks better? D's better. D's my answer. We good with that? Okay. Are we okay just doing one more of these? Yes, sir.
When we draw our lines, should we draw the arrows at the end?
Yes. You don't necessarily have to because we're really just trying to figure out which one works the best with the data. But technically, yes, you should have the arrows. When we did this first real world problem, though, would I have an arrow going that way? My age, can you have negative age? No, so I wouldn't have an arrow there. So for these that are like real world, I only exist in the first quadrant. This one, there's no context to these numbers, so that's why these I did put arrows on. Does that help a little? Okay. Okay, let's look at number 2. Always start to eliminate answer choices. What kind of slope is this? Positive or negative? Positive. Okay, it's going up, so this is positive. Which answer choices can I get rid of? Those have negative slopes. Don't graph those. Okay, what's my M? A. And I'm going to write it as 2/1. Remember, for graphing purposes, I want to have a rise value and a run value. What's my B? 3. So I'm going to begin at 3 and I'm going to go up 2, right 1. Opposite of up to the right, down 2, left 1. Wait till we're done. Down 2, left 1. Draw your line. So this one, there's no context to these values, so I'm going to put arrows at the end of my line. Okay, what's my slope for B? Very good, 1/2. What's my y-intercept for B? So I'm going to begin at 3, and how am I going to move? Up 1, right 2. Or down 1, left 2. So, which of these is a better representation of the data? A, the first one. See how all the points are really close? B goes through the data, but it's not nearly as steep as it should be. We good? How do we feel about our line of best fit? Okay, I will tell you. They're not perfect, are they? They're like guesstimates, okay? Now, when we do our linear regression, we are going to find the 100% accurate line of best fit. Okay, this was guesstimating, educated guessing. Okay, now we are going to go to our linear regression, and we are going to use our calculator to do this. Okay, this is going to be 100% accurate line of best fit. Okay. So, we have a table. Notice there's calculator steps. First thing we should always do is clear our calculator. So turn your calculator on. We want to clear it between every problem. Second, plus 712. Clear your calculator so it says this. Please, please, please make sure we're following along with me because there's no way to do an accurate line of best fit except for on the calculator. Do you have a question or you're stretching? Okay. We good? We all have our calculator cleared. Okay. It says go to stat. Stat is right below the delete button. Do we all see that? It's to the left of the arrows. Hit stat. Follow along with me so our screens all look the same. So hit stat. And then we're going to do enter. And now we should have a screen that looks like this. We good? Then it says enter your X1 values in list 1. So, the top is my X, the bottom is my Y. So I'm going to put my values in for L1. Put your X values. Guys, I would use your finger as a placekeeper. I promise you the hardest part about this is typing the data in correctly. If you type the data in wrong, you get the wrong answer. Put your calculator flat, so you only have to use one hand with it. Then use your other hand as a pointer to type in 0, enter, 10, enter. Go through, move your finger, hit enter after each X value. Normally, guys, the X's are a little bit easier to do because there's normally a pattern to the X's. The Y's, there's not going to be a consistent pattern. Okay, so we're going to arrow over, and we're going to type in our Y values, the temperature. Does it matter the order you put this in? Yes, because your X and your Y need to be paired together. If you mess up on one number, you're going to get the wrong answer. That's why I'm saying use a finger as a placekeeper and use your other hand to type it in. What if your two columns aren't the same length? You did something wrong. See how my table has values paired together. If your calculator has one list column, one list longer than the other, then you did something wrong. Okay? Do we all have the data in the calculator? Do I need to wait? Anybody? We all good? Okay, so now to find the line of best fit, you're going to go back to stat, arrow over, see your little arrows around this circle, arrow over to where calc is highlighted. We are doing a line of best fit, so you're going to go down to linear regression. Lin reg, AX plus B. Please do not ask me why the calculator chooses to use AX instead of MX. I have no idea. It's not very smart. Okay, what is the A value, do you think? Your slope, your M. Okay, what's the B? Same thing as before. Your B, your y-intercept. Okay, then you're going to hit enter. So we all have number 4 highlighted. Hit enter. Then we have this long list. You're going to hit enter a bunch of times until calculate is highlighted. Enter, 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 enter. And then it does its magic, and there you go. There's your A and B value. Did we all get the same values? If you didn't, you typed in your table wrong. If you did, good job you. Okay, we are going to round to the nearest hundredth. So, round to the nearest hundredth. Okay, which is 2 numbers after the decimal. Okay. So, find the line of best fit. Well, I have my A and my B, so it's Y equals, what's my M? Negative 1.0. Does the 1 round the 7 up or keep the 7 a 7? Keeps it a 7. 5 and up rounds your number up. So you look at the number 1 past the hundredth spot. Okay, it's a 1. 1s do not round it up, so it keeps it a 7. X plus, what's your B? $92.8, and then let's look. It's 6. A 6 rounds it up to a 7. And there's your equation. That is an accurate prediction of, or an accurate representation of the given data. Okay? We good? Now, we do this in real life. Okay? When you look back at the beginning of COVID, there was a lovely curve. It wasn't a linear function. It was the type of function we're going to do next. It was an exponential function. But they used their curve of best fit to make predictions of what our COVID numbers would be in the next month or the next month, okay? So in the real world, we use this, okay? Estimate the average temperature for a city with a latitude of 48 degrees. So it's 48 your X. Oh, it's frozen.